decomposition, and balancing is conversion of input and output to a data flow diagram process when that process is decomposed to a lower level. And balancing DFTs. Balanced means number of inputs to lower level. DFT equals number of inputs to associated process of higher level DFT. Number of outputs to lower level DFT equals number of outputs to associated process of higher level DFT. And balancing DFTs for the one input and one output and two inputs and one output, we can look in this picture. And data flow splitting. What's data flow splitting? Is when a composite data flow at a higher level is split and different parts go to different processes in the lower level DFT, and the DFT remains balanced because the same data is involved but split into two parts. And again, balancing DFTs is continuous. Example of data for splitting composite data flow is here, and example of data flow splitting disaggregated data flows is here. And in this table, advanced rules governing data flow diagrams. And for different types of the DFTs, and one of them is current physical, and current physical is process labels identity technology uses to process the data. And data flows, the other is data flows and data stores identify actual name of the physical media. And second one is current logical, and physical aspects of system are removed as much as possible, and current system is reduced to data and processes that transform them. And third one is new logical, and new logical includes additional functions. Obsolete functions are removed, and inefficient data flows are reorganized. And last one is new physical, represents the physical implementation of the new system. And completeness is DFTs must include all components necessary for the system, and each component must be fully described in the project dictionary or case response repository. And consistency, the extent to which information contained on one level of a set of nested DFTs is also included on other levels. And time is not represented well on DFTs, and best draw DFTs as if the system has never started and will never stop. And iterative development, analysts should expect to redraw diagram several times before reaching the closest approximation to the system being modeled. And primitive DFDs, lowest logical level of decomposition, decision has to be made when to the decomposition, and is here first. And rules for stopping the decomposition when each process has been reduced to a single decision, calculation or database operation, and when each data store represents data about a single entity. And when the system user does not care to see any more details, when every data flow does not need to be split further to show that data are handled in various ways. And when you believe that you have shown each business form or transaction online, display and report as a single data flow. When you believe that there is a separate process for each choose on all lowest level menu options. And gap analysis is the process of discovering descriptions between two or more sets of data flow diagrams or discrepancies within a single DFD. Ineffectiveness in a system can often be identified through DFDs. And using DFDs in DRP, in this picture, IBM credit composition primary work process before BPR. And again, using DFDs in DRP, BPR. And electronic commerce application, process modeling using data flow diagrams, and process modeling for Pine Valley Furniture's web store, and completed job station, and began translating the web store system structure into data flow diagrams, and identify 6 high-level processes. And in this table, electronic system structure of web store and corresponding level 0 processes. And level 0 data flow diagram for the web store is here. And what's the summary in this chapter? And firstly, in this chapter, we understand logical process modeling via data flow diagrams, and draw data flow diagrams of well-structured process models, and decompose data flow diagrams into lower level diagrams. And then we learned balance high level and low level data flow diagrams, explain differences between current physical, current logical, new physical, and new logical data flow diagrams. And last one is use data flow diagrams for analyzing information systems. And thank you for watching this chapter.